How you doing? This is Dr. Bao. I'm speaking to you a little belatedly on the topic of Chapter 9. I know in the current week, um, we're at this is sort of the last weekend of June, not sort of, it is. And so I'm sort of speaking to material that was sort of last week, to be honest. Um, but it's dense enough to where um, I wanted you, I wanted to go over it with you. There is a particular this is a lot of material in this book, and I realize that. But um, as I make these videos, even though I'm a little bit behind on them, my point in making them is to at least just kind of discuss some big picture things. So I had slated for the previous week chapters 8 through 10, and really we have coming up 11 and 12 in the week we're about to enter into. So a little bit behind in making these. Now, as I prescribed NAFLIC, I gave you actually kind of a NAFLIC assignment very recently. In fact, I'm recording it on the evening that it's due. And that's kind of it's a flavor book. It's there to give you some things to think about, as was the McGill-Chris things on the divided brain. So these are um, just some context, basically. I do have a pretty significant bids assignment coming up for you that I'll stretch across the coming holidays. So in a lot of ways, it's a little. I wasn't quite able to hit one a week as implied by the syllabus. I gave you a bids assignment. I gave you a kind of a tools assignment. Not really. And getting you to think about the divided brain. I wanted you to think about presentation. I also want you to think. I think we're about a month off from the class conclusion. So I want you to think about some of your own data, and I'll be a little bit more specific about that soon. I always do a terrible job of dating these videos. Their reuse is a little strange, but the material such that sometimes this stuff isn't, it's too reusable from year to year. Anyway, um, these are long, thick chapters, and they're really dense. So um, I get that. And I haven't really stressed you on them. But actually, some of this is the chapter 8 material I'm actually giving you an assignment on. The chapter 9, you're kind of using indirectly by having some dimensions from um, this airplane data. So, anyway, um, I think that the biggest thing we get into at chapter 9 in dimensional modeling and how it's different just from straight, relational database modeling is that entity relationship modeling is that it actually gets us in touch with some terms from the book. So if essentially, and really from the tool, I'm sorry. So the tool, I got open flights data open again, and the tool becomes this way to kind of see measures and dimensions in place. And so there are facts, and of course these become these measures. And then there are dimensions, which kind of give them some context. And this is actually literally why we have this lingo. And again, and I said this multiple times in the past, but this lingo is very consistent or similar to the lingo used um, for something like Power BI as well. Yeah, boy, I got a really terrible um, internet performance tonight. Yeah, those tiles are just taking forever to fill back in. All right. Anyway, what does that mean for us? Well, that means then that if we get a diagram like this one here, sorry, let me close that. If we get, if we get a diagram like this one here, um, we can kind of get a sense of these facts and dimensions, right? And so what becomes sort of the difference between these? Because we really want to talk about facts, dimensions, and artifacts. I'm sorry, attributes. Um, there are different types of facts depending on whether they can be added together, and so that what that means is the degree to which they can be aggregated. And dimensions have different hierarchies and have attributes to define who, what, when, and where, and how. And then there's basically the granularity of this context and just levels of detail. So facts and dimensions and attributes can be organized several ways, and as we organize them, that becomes a schema. And the choice of schema depends on variables such as the type of reporting that the model needs to facilitate, the type of BI tool. So since we're using something like Tableau, that becomes pretty straightforward. So basically, we could see here in like a this figure here, which is from the book, that we're going to have these facts or measures and dimensions or context. And so the measures dimension language is actually literally used in the tool. So for instance, if we have sales here, so this fact is a pretty core portion of this dimensional model. And then there are multiple dimensions that let us actually kind of look at these measures in different ways, right? And so we've got the dimension of the customer, the date, the item. And so the idea would be, well, what's the difference here? I don't get it. Well, the facts is kind of the way we were able to actually reconcile between each of these dimensions. And yet we sometimes want to show the data on a particular dimension. So we can see that here, right? We're showing the data, on the dimension of the ICAO code, but the fact is actually, how much traffic do they have? And that's why each of these bubbles here are of a different size, right? So that's one way to think of it conceptually. And so, um, our fact table is going to contain the keys that allow us to kind of get out to each of these dimensions. So this becomes sort of particularly in Tableau, the means by which these things are visualizable. So in a lot of ways, I would want to reduce the complexity of looking at chapters 9 and even 10 by saying or encouraging that the fact of the matter is, no pun intended, um, the dimensions become what's of interest in terms of what do you want to show in the visualization. And then the facts becomes the variance within the dimension, so we can kind of get characteristics. So each of these dimensions are going to have additional attributes. They're not shown here, right? And so in a lot of ways, this fact table just becomes that which we're using to relate these things. Um, and then, we can decide on what level of granularity we want to go into. And so here we are. Um, we have this um, the ability for each of these foreign keys to help us relate these dimensions. Um, and so the idea then is that the primary key from every dimension becomes this surrogate key in here, where that at least makes these things cross-relatable. And that becomes sort of like this join that we get back here in the data source, right? The reason that um, the data in airports.dat and the data from the 2016 table from from Wikipedia here, when I put that together, the fact that they're relatable is because there are a number of surrogate keys from each primary key here in the middle. So we then want to establish, of course, what we mean by granularity is that it's possible to look at more than just what the foreign keys provide. So this is that concept of joining. And if you read the chapter carefully, I mean, you'll see what that means. Um, and so, this is a pretty basic example of a dimension. So this is the dimension for a product. This is the product key. But what kind of really matters is that we have each of these additional attributes in this dimension. And the utility of each of these attributes is that they allow for the types of things we'd want to basically develop either visual queries on, or the things that we'd want to develop to do our visualizations. A lot of the intelligence in business intelligence, when you're using a business intelligence tool, is going to be in the mind of this subject matter expert and sort of the mind of the analyst, as it were. And so you want these different queries to help automate this aggregate flow. All the material we covered in chapters 4 through 6 in this book. This just sort of talks about what are the things to think about in preparing the data so they can be used. Um, Dimensions can have a hierarchy, and so what the dimensional hierarchy means is that um, these become sort of the way that we're able to get, I guess, multiple distributions of the fact. Let me back it up a little bit and sort of make the point here that um, in the facts here, because I kind of missed these facts, we kind of have these really three primary types of fact. We end up having these additive facts, okay? And the additive facts um, are basically uh, they're a measure of the fact table that can be added across all the dimensions. So the idea is that is there some aspect of the fact table that we can then do a through a join a mapping to all of the dimensions. There are semi-additive facts where there are measurements in the fact table that can be added across some dimensions but not others. So pretty much, we could have like a bank balance. This is from the book, or number of students attending a class, or inventory levels. So not every dimension involved in the model is going to be able to sort of add across that fact. Again, like bank account balances and the number of students attending, that might be a part of a problem. The ability is we don't have perfect additiveness. So, for instance, just taking the airport stuff here, um, we are going to have things like the rank here, the code, and those things aren't additive here. But these totals here, traffic totals, those would be additive. So these changes here, are not really additive at all. So non-additive facts are measures in the fact tables that can't be added across any dimensions. So for instance, ratios, these in case because they're percentage increases and decreases, are ranks here. They don't make much sense in terms of adding them together. We say they're additive, but the truth is that through any kind of aggregative summarization or data reduction, the truth is when you find the average or the sum or the product, you're actually reducing that data, right? You're coming down with a single value to represent a component of a more compound value. So those terms are just there from the book, and so it's worth keeping those in mind. And this is kind of intuitive when you play with um, Tableau. And I guess soon here, I'm a little by the tune of a couple days late in getting some of these videos out, but um, soon you'll be able to uh, get a little bit more exploration through Tableau to see some of these things in action. So what's important is you realize, and I'm trying to do this in the videos, there's some alignment between what you cover in the tool and then what you're actually reading in this book. There's actually some you know they have a relationship. So back to dimension hierarchy. So another aspect of the business context created by dimensions is that they're often hierarchical, and that's just code for they let us group by, right? Group by city, group by country and region. In fact, there's another version of a lot of the maps we would make, right, where the map itself becomes shaded, right? They called filled maps here in the Show Me part of Tableau here. And so that wouldn't really relate here, but if we had some kind of dimension that was collected by, well, look at this aggregation here. So for instance, if I had states, cities, and postal codes, so the country breaks down into provinces or states, which breaks down into cities within those provinces or states, which break down the postal codes that actually further subdivide these cities or other types of things. So it gives us different levels of granularity, and that's really what that's about. The geography there becomes kind of a good sense of that. So the book talks about dimension keys and surrogate keys, and the key concept in constructing dimensions, sorry, is that each row of a dimension table is unique. And so the idea there is it kind of represents a record, right? So in a dimension table, the primary keys are a single field compared to facts where they're actually almost by their definition, a grouping of foreign keys. Here's a good example of that from here. this lat long here, is a grouping of variables that lets us kind of uniquely get at how we were able to map some of these things here. Um, and so that's kind of how that ended up working as we've been playing with this. Okay, good. So that's kind of one of these differences here. So if we look here, we have product in geography, and each has a single field, which is a key that's kind of representing that dimension. So uniquely representing one row. So for instance, we'd have an address would have uniquely a country and a state and a city and a postal code. A product would uniquely have each of these things here. Um, and so they're primary keys for the respective tables. Um, but one of the interesting things about dimensions in terms of this concept of surrogate keys as a primary key, we can see it um, right here in this picture. The surrogate key is often generated by the database system, and it's an integer whose value is meaningless. And then effectively, um, this becomes sort of like a unique identifier that isn't conflated with any of the actual data. And that kind of makes sense. So what they're calling surrogate key is usually sort of like an auto-generated key. So it's some sort of unique number, and it just represents the record, but it doesn't have anything really to do with the record itself. So that just becomes interesting because we don't then have to rely on variations or perturbations in the key itself. Um, so if we go here, then we can kind of see that, for instance, um, we have a customer surrogate key, which is going to be like, I don't know, let's say it's the 99th customer we've had. Well, a good example is even the ID numbers they give you in the university, right? That's really just some sequential number. But we could have some sort of natural key. That could be like your social security number or something where it's a lot more uniquely you. And just kind of reconciling between these two is kind of what really matters. Um, the book also talks about smart keys, and smart keys are really just keys that kind of become maybe a little bit more, um, I guess, um, putting a little bit more metadata or having a little bit more design to the string so that the key itself can be parsed. Um, and it was just this attempt to make a slightly more intelligent surrogate key. So a surrogate key is really just like an auto increasing number that we have in a lot of tables so that we can uniquely identify the record. Um, and that's probably this whole key business. And so in many ways, if you think about it, let me give you a better example of a way to think about this entire two chapters. Um, you notice how when we go to the data source, this data source is being brought together just by opening up these two different connections. So once we've opened them from the connections and made some manipulations here in the file, then this becomes the difference between just the basic uh, relational data or just tabular data in the case of the airport's text file. So it's the difference between those and what we actually have inside the tool. So inside the tool, it's a lot more prepared. Now, in a much more quote unquote enterprise system, these things probably would have been put out um, into um, into some kind of you know data mart, data warehouse. These things would have been staged a bit more. So we're in a desktop BI tool like we're using, it's a lot more straightforward, which is okay. I mean, there's nothing wrong with that. So the book then talks about schemas, and we'll get into that topic right here. And schemas are then these arrangements of these dimensions, facts, and attributes. So if we want to put them together, we sort of end up being able to describe our design for business intelligence, right? And don't forget, this is a dimensional design instead of any relationship design. So we're using kind of different notations and everything. So we're going to look at star, snowflake, and multidimensional. But the idea then becomes, well, why do each of these matter? And it really has to do with what is the nature of the data, was the nature of the analysis we're trying to do. How does it adhere to the 5 C's and that kind of thing. So the star schema really just sort of says that we have this fact table, and the fact table is here we are. Fact table is kind of the crossroads for all of our dimensions. And in general, this is probably what we're going to do in almost everything we do. And surprise, surprise, that's kind of what's going on here, right? This here is the join between these two. So this is sort of like your fact table, and it's coming off of these two data sources, which are kind of constituting the dimensions you'll select. It's not quite that straightforward because you can see that what becomes available to us from each of these, there are measures and dimensions in both, right? So it's not as cut and dry to say that, well, the join table is in the middle and everything else is dimensions, but um, these are becoming a lot more conceptual than they have to do with the physical implementation. Okay, now a snowflake schema, come on you. Snowflake schema you can see is going to be sort of hierarchical, um, but it's basically like the star schema, but all the facts are surrounded by denormalized dimensions. So um, we basically stretch this out into a hierarchy, and this kind of becomes denormalized in the sense that they have a lot more of a linear dependency. So the fact table stores foreign keys to the lowest level of the dimensional hierarchy, and then we're able to kind of um, go on up there. So you can see, and I know it's strange to see up because I'd almost think that the sales itself, the facts would be on the top, but basically we're able to derive through filtering, right? So essentially, we still have the key is all brought together here, but we have a product, which then leads to a subproduct, which then leads to some sort of product category itself. Um, so each of these is sort of a way to um, um, expand out, if you will. Now, the reason it is top-down hierarchical is that, first we find a category, books, then we go to subcategory, nonfiction, and then from there we can actually look at actual product keys. So as much as it seems to emanate from the top, but this makes sense because what we're drilling down into is the facts anyway, and the dimensions are a way to hierarchically let us get into there. And so um, that's kind of my best understanding of it. Honestly, before selecting this book, I had never heard of that particular terminology. I think this star schema becomes the most common here. We will have a multi-dimensional, and what it just sort of says is we're starting to relate, um, obviously, on more than one dimension, more than one um, dimension used to help us filter down through the facts. So, um, in a lot of ways, this is, on the one hand, pretty normal, um, but on the other hand, pretty complex as well. So if we think of like a pivot table from Excel spreadsheets, um, it kind of gives us a sense of being able to look at least a 3D conceptualization of more than one. And this is kind of the root of where these online analytical processing or OLAP cubes come from. So pretty advanced, but I think that most of what we'll do, we'll be able to get away with something like that there. Um, Now, we looked at some of these dimensional models, um, and we usually kind of say that they're all plugging into a single fact table. But it's also possible to basically have, multiple fact tables. So we could have store sales and store inventory and kind of sub-aggregate our dimensions based on them, right? Now they're coming across, you can see in the case of the query, it looks to sort of look at customer by store, or looking sort of items by date and buyer. These would be the types of queries you do, and they're really coming from more than one fact table. And we kind of have something a little bit more like that going on, believe it or not, in that's not what I want, this, in this open flights data example. So that's actually a lot closer to what's happening with us. Um, okay, perfect. So what does this have to do with anything? Meaning that, um, and don't worry about this. The question becomes, what's the difference? And I think what Sherman's trying to do at this stage is give us a sense of that it becomes less complex once you're inside a tool. Let me just go grab a picture here. It becomes a lot less complex once you're inside a tool to get over to this dimensional aspect, right? To kind of do this dimensional modeling. So if I were to go here and just pop in a new slide, I'd have us look at this from the book, right? So, um, because when we're talking about, and this is really from chapter 9, but we're talking about operational systems versus business intelligence systems, that kind of gives you a decent sense of really when we would be in more of an ER, relational database modeling um, perspective or mode, and then versus a BI mode. So that's probably the biggest thing, and I said this earlier in the video, but I'll just repeat it. The biggest thing for you to keep in mind in distinguishing between these two different chapters is to say, all right, um, this is a lot more of like the source data and what I have to do to get that all cleaned up and set, and this has a lot more to do with the dimensional modeling data and to get all that set up as well. So we can kind of see ER as being operational and dimensions as being BI and analytics. Now that is a oversimplification, but for comparison, it makes a little bit of sense at least for our learning. So we really want um, uh, for online operational systems, we really want highly normalized models. Um, we want it's because the data is constantly in flux, and what that means is that um, oftentimes these are real-time operational systems, and therefore they're designed for integrity and high transactional throughput. And so um, we really want normalized models. We want minimum redundancy, limited index use. And I haven't talked about indices previously from chapter 8, but the idea is that you want to run, and most relational database management systems will establish indices or indexes um, because they make sorting and searching really, actually forget sorting, searching a lot easier. Sorting is a cost of indexing. Um, so the idea then is that you're going to incur that cost because we're really interested in sort of the advantages with respect to speed and whatnot that's going to give us. So um, what a database index is going to look like is going to be sort of an additional um, set of information to help us find something a lot easier, right? And the index is usually kind of kept sorted. Um, this is a pretty decent picture. I'm trying to pull one in for you. The idea here is that we have um, the index here gives you really a quick way to go and then look up things here. Assuming that the data is at least sorted somehow, then the index gives you a really quick way to go find things. So indexing, this is another reasonably decent picture of it, or not. Uh, well, that's not what I wanted, but still, that's just what I wanted to show you as an example of just a way to think about the indexing. That's actually what I wanted right there. It becomes a way to have a map to the actual data because the actual data is getting huge, and we just want to have a way to quickly get to it. So, um, and then of course it's going to look for efficient use of storage um, by the elimination of inconsistencies, um, and so maintenance becomes a little bit lower. Whereas when we do this dimensional modeling for BI, it's kind of extracts from this operational data. Therefore, as extracts, they're not updated as real time. These are usually, aggregations and simplifications of the data. We really here we're looking for optimizations in query performance, right? How can we look at the data instead of just making sure it's stored and tidied okay? So we actually end up increasing redundancy, and that's usually through a lot of denormalization. Here's a good example. This data we have here joined together is highly redundant, but it makes the querying and visualization a lot easier. Therefore, the redundancy is going to increase storage space. It's going to basically allow us to pull together inconsistent data so we can impute new consistencies. Therefore, since there's a lot of manipulation and extraction, that's going to increase the overhead of looking after it. So in an ER model, we are having the ability to kind of relate, um, looking at stock, um, basically from the manufacturing catalog, as that relates to then being the source of an order line item, which then, of course, contains one or more in the customer order, which then, of course, is related to the customer, which is related to some sort of call they made to initiate a transaction, which, of course, was findable through um, looking at different types of calls. So another way to look to this is say that we took a support call from a particular day of customer calls, and that was in regards to a certain order and a certain item on the order, which is a part of our inventory, which goes back to there. So all these tables, you have to match that back together through the SQL statements and relational database management systems. On the other hand, if you make the sales facts themselves the central fact table, then we have the dimensions of customer, product, geography, and time, and we can essentially drill down through their attributes to do some open-ended queries. So we don't really, for the sake of wanting to do this analysis, need to keep these tidy and apart. We're willing to deal with some redundancy to get better analytics. And that's again a great parallel to why do we do chapter 8 versus chapter 9. And so essentially, when we're looking at, and this is a great example, I was kind of give you this example from thinking about BI, Tableau as a BI tool, but the dimensions are what we're going to select to have a look at. And the facts, of course, are either the straight reporting of the data and statistic itself, or the data plus the visualization. So this combination becomes very much the relationship between having dimensions and measures and the attributes that go into them. So hopefully that kind of gives a good sense of why do we have dimensional modeling? Like why are we bothering? And a decent example I think is through this business report. In fact, I think it's a lot more of an interesting example than rather this OLAP analysis. Of which case, like a pivot table is a good example. Um, I should soon, not in this video, show a pivot table. Um, we're getting some of the same outcomes from Power BI and Excel. It wasn't too many years ago that this class was just only Excel. I don't know, I'd be willing to take it back to that. But what I mean by this then is that it's possible to do a lot of the things that we're trying to do or, looking to accomplish with a tool like um, Tableau or Power BI with um, just something like Excel and it doing its pivot tables. So that ends up becoming just a decent way to figure out why we're doing this. So um, if we kind of consider fact tables, we're going to have transaction fact tables, sometimes periodic fact tables, accumulating fact tables. Each of these become a sense of what are the types of fact tables we're going to be putting together. So let me just snap something in here real quick, assuming I can find my mouse. There we are. Sometimes I think in Windows 10 the mouse just suddenly goes to be AWOL a little bit. I'm going to put in a new picture here. I'm going to drop this in. And so the idea behind this, and it's from the book, is that we really think about uh, several different of these types of facts, right? So these transaction facts, these periodic facts, these accumulating facts, and they're each going to have these different properties, right? What is their granularity? Their grain. So is it one row per transaction, one row per time period, one row per lifetime of an event? Um, then we have, so what is the date dimension? So what does this have to do with the temporal nature of this? Generally, the transaction is going to be the lowest period of granularity. In periodic, obviously, we're going to have the definition of the period. And of course, since it's accumulating, it is lifetime of the event or lifetime of the the fact, then they're going to be multiple per row. There'll be the least number of dimensions in a transaction because it's essentially point in time. Generally in periodic, we're going to be averaging, and that is what I mean by number of dimensions is that it's going to be sort of middling, and then you're going to end up having and accumulating quite a few dimensions because we're kind of looking at summative or final analyses type of thing. And you can read the rest of this. So it's interesting how these different fact types become, the basis of really what type of dimension analysis you're going to do. So, what are some advanced dimensions and sort of concerns with them? And what I mean by that is, are there any special cases of dimensions and facts that are worth um, staying cognitive of? One, of course, is that um, there is the date dimension, right? And so the date dimension then leads to a particular um, well, the facts, of course. Let me say this differently. Here we have the um, basically the circuit keys of this fact table. A couple of attributes within it. Clearly, a very serious um, circuit key for um, the date here, and then all different ways to kind of break the date out, ways that we can get multiple snapshots or epochs or time frames of a date, right? Does it lie within a particular calendar month? Does it lie within a particular season? Is it a holiday? All these types of things. So this then kind of gives you the sense of you have a lot to think about, and designing date isn't a monolith. You have to kind of get a sense of what's going to matter the most given the context of the dimension. And don't forget, that's what dimensions are there to do. So, and that's because any straight date like you have here in the fact store, the way dates are typically stored in computers is just the number of seconds or milliseconds past the beginning of some epoch. In general, the widest definition of this on the internet is the 1st of January 1970. So a point in time can be expanded in the context of a lot of other subdivisions of time. And so that's just a good example um, of, we can look at time as a fact. Okay, and time as a fact says that, well, it's just a particular slice of time, but time can also be a dimension, particularly if we think about time and date and looking at various sales periods over a particular period, sorry. um, and we really have a lot of granularity, right? How far do you want to drill down? Do you want to drill down to time periods? You want to drill down to some kind of description? You want to look at AM or PM? So then we can even take it further to say, well, what is the granularity if we want to look at things down to the minute? So that's a good example of you have a bit of design choice and levity, even in your dimensions, right? So they kind of require some type of additional manipulation and design on your part. Here's a way to kind of characterize time periods, and we can go across time zones. So all these just say that these are design considerations for you in this um, fact versus dimension and attributes business. Um, and then, of course, there are also times where we really want to look at the fact table references a dimension multiple times as a foreign key. And this is because we end up maybe just going through roles, right? So the idea was that, but it depends on the context of how we're asking. So for instance, the fact internet sales table has an order date key, a due date key, and a ship date key. And so these are all going to be, in terms of, if we look at the dimension, they're all going to be dates, right? So the point is that we have three different contexts through which we want to actually access this. And so when was the order made? When should the order have been fulfilled by, right? And then when did it actually ship? And each of these instances, in terms of dimensions, they're going to share the same characteristics. So it depends on the roles we're working with. Now, one of the interesting things as well, if we go here, is that dimensions are usually derived from operational systems where we're looking at transactions. So sometimes we need to kind of be down at this, uh, uh, what am I trying to say? Transactional level, right? So the reason this is considered degenerative is that sometimes we need some information in the dimension to be able to get into other details of the data, and so it's degenerative in that we're actually going back to more of this transactional mode, and we're a little bit less in the mode of just keeping these things additive, semi-additive. So it's our ability to generate back to more of the transactional stuff when we need to. Um, then facts almost always have measures. Let's kind of look at it here. So facts almost always end up having measures, but there are some exceptions. So these exceptions occur when the business event does not create or monitor any quantifiable measures. We just kind of want to know that the event happened itself. So it kind of becomes a factless fact. For instance, like, students attending a class or patients visiting a doctor. We didn't really measure that other than it happened, right? Um, if we, for instance, paid tuition, then that would generate a bill and that would generate some kind of payment. Um, but those are other facts, right? The actual fact of you attending. And so we can have some of these flag variables, as sometimes in programming we'd call it, just to say something happened. So that's just a different type of fact. Um, Another type of fact to kind of be concerned with is consolidated facts. So fact tables store data about transactions or business events representing certain things. So fact tables are highly normalized. They're in transactions and operations, and they're usually correlated to business entities in the operational ER models. And so um, that's normal in terms of how we would look at data warehousing and data marts and all this. But a consolidated fact table, or fact tables that are separate and distinct in operational systems, and that they sort of aggregate multiple things to better facilitate reporting. So it's basically kind of like some digest of the data. So if we have a measurement period, date key, right? Then that's going to be kind of an additional consolidation of the fact so that it gives us access to things like the forecasted sales and actual sales. It's bringing together this product, customer, and geography, but the actual date key itself, I mean, what I'm saying is I'm storing in the fact that period, whereas we've usually in the previous slide considered that part of a dimension. So that kind of makes that a little bit interesting. So let's kind of review here, and I'll kind of cut this off because it's long, and I'll just do a separate one for chapter 10. But if we review here, then what the purpose of the entire chapter has been is that facts, of course, and usually there's this in the star configuration, there's this central star schema, sorry, there's this central um, um, fact table that has all the keys to map out to the dimensions. But obviously, some of the information we're interested in, you can see things like revision number and order quantity and unit price. Some attributes go along with them. But we're also going to use that as an opportunity to then map out to these dimensions, which usually then when we're doing reporting, when we're doing BI, these are the what do I want to show, right? What are the I want to show, location and number of passengers. So these dimensions and hover are become ways to filter through that if fact internet sales entity there in the middle. And that's going to be a highly denormalized, massively aggregate table, but it makes it convenient to drill down. And again, the good example of that is what's been going on in Tableau, right? This is a highly um, mushed together table of the two of these. So we have these facts, dimensions, and we have these attributes, and that's how this comes together. I'm going to wrap that up for chapter 9. I think that's enough. Again, the point of all this is that you have a sense of, to put it the most simply, what happens when we're playing with the data in here. And again, we took no real database sources. This is just Excel files and flat files. So a video coming up soon within the next couple of days is, of course, getting us back to some chapter 8 things. But for now, these are the concepts from chapter 9 that really tilted towards what we're actually doing in something like Tableau. All right, I'm going to cut that off here so I can get this uploaded. I will give you one on chapter 10 pretty immediately here. Thanks a lot.